Okay, and we are live. All right, please do me a favor. Open your lesson number 5. This lesson is going to be mostly me saying stuff. You will have the opportunity. You will have the opportunity to follow me and ask questions, of course. Okay, it says here, what are the roots for 5x squared plus 20? Well, let's find out based on the work that we have done so far on the different ways that you can find the roots. So, like I said before, you're going to be following me since I'm recording and I can't really stop for a long period of time. What are the roots? Well, one of the methods that we can use is factorization, right? If it is possible, we can factor. Let's see if that is possible. If we look at 5 squared plus 20, we can factor out a 5. Sorry, that 5 doesn't look nice. We can factor out a 5 and we're left with x squared plus 4. Is everybody okay there? Right? And now we can also continue doing this by setting up this equal to 0. And trying to find the roots. 5 will never be equal to 0, so that's not a root. Not a root. Here we have x squared equal to minus 4. Is everybody okay? I just moved the 4 to the other side. And now we're going to get the square root of negative 4. If you do this in your calculator, it will give you an error. And it's very interesting the type of error that you get. Okay, so let's check the calculator for a moment and let's see what kind of error do you get. I'm going to go to menu and number 1. And I'm going to ask the calculator to do shift square root, which is this x squared. And I'm going to put it in parentheses because it's minus 4. And I want the calculator to understand that minus 4 is inside of the square root. Just to make sure. And look what I have. Error. But it's a specific error. It says non-real. So that means that this is not found in the real numbers. Inside of the real number is not found. Okay. Is everybody okay so far? So we do have a problem because so far, apparently, we don't have roots. We have something like this. Yes? We're going to come back to this for a moment. Let's double check another way to find roots. We're going to use graphing, right? We're going to use the graph, which you have seen before. And we're going to enter the equation y equals 5x squared plus 20. And we are going to be looking at the answers. Is everybody okay? All right. Let's go to the calculator one more time. And let's pull out the graphing section of the calculator. I don't know where to put that. Hopefully you're following me. I'm going to go to menu. And I'm going to go to graph. For me is 5. For you is 3. I'm going to delete that. And I'm going to enter the new one. Please do it also because I want you to have the experience of that, right? I'm going to enter that equation exactly as it appears there. 5x squared plus 20. And I'm going to ask to draw. Number 1, I don't see it. If you have the regular window, you won't see it because the y-intercept is 20. So this is very far on the top. What I will do is I will change my window. Right? I'm going to change my window right now. The window that I have look what I have. It goes all the way to 1, 2, 3. It only goes to 3, and the graph is showing me that it goes all the way to 20. So I need to make this bigger. I'm going to go to my window settings, and I'm going to change the window. Yellow and window, and the X is okay. What I'm going to change is the maximum Y. It's not going to be 3.1. I'm going to put 20, at least 30, because it's going to, we need the space to go higher. And definitely, we don't need the minimum to be that, but we leave it like that. Now, the scale is not going to be 1, 2, 3, because we're going to go all the way to 30. So maybe I'll do it every 10, 20, 30. Okay, so I'll do 10 for the scale. I change only 2 numbers in the window. I change the maximum Y to 30, and I change the scale to 10. So it does not go one by one. I'm going to let you play with your calculator for a few seconds. Commercial time is running. I'm going to exit here. By the way, you can always go back to the video, and if it was too fast, you can rewind the video, right? And we're going to draw it. Look what happens. We had a problem. What's the problem? I don't know if the microphone is going to pick that up. What's the problem? It does not cross the x-axis. So let's bring this down to the lesson. Let's bring it down here. And no x-intercept basically was what it is. No x-intercept. I have a question for you. Even though it does not have an x-intercept, does it have solutions? The answer is yes. Because somebody made a promise. And the promise is that you're always going to have a solution for polynomial functions. How many solutions should you have? 2. The degree is 2. So your expectation is to find 2 answers. So let's write that down. Degree is equal to 2. We expect to have 2 zeros. Now you understand why we don't call it x-intercept at this level. We don't call it x-intercept because not always you're going to have x-intercepts, as you can clearly see in the picture. So we have to use a different name, which is allowed. The other name is called zeros, but it's also called solutions. We can use the word solutions. Okay. Now, we can see that if you use the factorization method, we get errors. And if we do the graphing, we have no x-intercept. And it's because these 2 methods are trying to find x-intercepts. So they're not going to be able to find them because it doesn't have one. But the promise is still there. The promise is that we should expect 2 answers. So we need to learn how do we get these answers. Questions so far? All right, let me open this because I'm hot. All right, so in order for us to find the answer, I'm sorry, I'm not going to move around too much because I need to be close to the mic. And hopefully the mic is on. If it wasn't on, I have to record this again. All right, so let me ask you a question. If you lose this pen in room 220, You're not going to go to room 219 to look for your pen. You know, that happened one time. I found a student here in this room trying to find the jacket. And I said, what are you doing here? And he says to me, I'm looking for my jacket. And I said, I don't recognize you as my student. Did you lose your jacket in room 220? No, I lost it in 219, but 219 was locked. So, you're not going to look, by the way, that is a true story. I know it sounds strange, but it is. You're not going to look for an answer in the wrong place. So the first thing you have to understand is this graph that I have here. This graph, it shows you that there are other numbers in the world. You study all of your life this group, the green group. This group are called the real numbers. Do you remember the answer that the calculator gave you? It says, I cannot find it, even before kindergarten. Who could tell me what are the very first set of numbers that you study? Zero. Right, what? No, zero? When you are a little boy or a little girl, your mommy asks you, how old are you? 2. 1. But you would never find very strange unless you are a very special kid. It says, what's the smallest number? 0. They don't know the concept of 0 yet. And that's why the first numbers that you study are called natural numbers. Right? And the natural numbers are 1, 2, 3, all the way to positive infinity. Right? Then as you get a little older, you study something called whole numbers. Whole numbers is the same thing as the natural numbers with the exception of what? 0. You are a little bit older and you understand the concept of 0. By the way, this symbol means infinity, continuous. You get a little older and you study something called integers. Integers are numbers. Who can tell me what the integers include? Every step you learn a little bit more, right? What did you learn? What's the next one? Negative numbers. So you got -3, -2, -1, and this continues that way. And then you get a 0 and 1 and 2 and 3, and it continues that way. So you get the idea. Those are the numbers you study most of your life. Then you got the then you got the rational numbers that are fractions, right? Irrational numbers that are decimals, but they are real. So we can include here more. I'm not going to keep writing. You can search that. You got rational. You also have irrational numbers. All of these you study all of your life. But now you realize that there is another world out there, and it's the world of the imaginary numbers. Why are they called imaginary numbers? Because they have not better word for it. They didn't have a better, nicer, pretty word for it, so they call it imaginary numbers. Now, what is the reason behind imaginary numbers? Okay, let's talk about imaginary numbers now. Imaginary numbers. Imaginary numbers exist so that I can find the answers of negative square roots. Right? If somebody gives you a negative square root of 4, you say, I don't know what the answer to that is, because there is no numbers that multiply 2 times gives you -4. If you find 2 numbers that multiply together, the same number multiplied together gives you -4, you will never find it. Think. -2 times -2, +4. Negative 4, positive 4 times positive 2 times positive 2, positive 4. So you will never get negative 4. It has to be the same number. So we come up with a brilliant idea. And the idea is to separate what's inside into two sections. You see, the problem with that expression is the negative number. So if I separate what I don't like, this is like when you are home and you really want to eat that banana, but the banana has, half of the banana is bad. It's already dark and it's already, going bad. So rather than throw the whole banana, you cut that part and you eat the good part. You look at me like you've never done that. All right, you're rich. You don't need to do this for me. So we have the bad part here. We separate it, and we call that the negative expression, negative 1. We know the answer to this, 2. Positive or negative 2, actually, if you really want to be technical about it. And this one, we don't have any expression in math to symbolize that. So what we do is we come up with a symbol which is called I. So I is in reality the square root of a negative 1 is I. We'll look at that in a moment. So let's go back to the calculator. Remember, and this ties very nicely with lesson number 3. So let me go back a little bit and go to this problem. You remember this? The calculator was giving me an error, remember? But because the calculator was looking in the wrong place, just like my student was looking at the wrong place. Menu and 1. And I'm going to put the square root again of negative 4. I didn't put it in parentheses, but it's good to put in parentheses. It gives you an error, right? And the calculator says, I'm going to give you an error because I am looking at the wrong place. It's looking where the real numbers are. So what I'm going to tell the calculator is please look at the other world. So look what I'm going to do. Exit here because it says press exit. And now I'm going to go to what it says setup. I don't know if you can see in the menu key on the top it says setup. Press yellow and setup because anything that is in yellow you got to press the yellow key. Now we are going to go down until we find the right setup. That's not it, that's not it, that's not it. I show you where it is. I keep going down and look what it says here. What does that say? The numbers, I'm going to look only in the real world. I'm going to look in the real world. But I don't want to look at the real world because this is not a real number because it's the square root of a negative number. So I'm not going to choose F1, that's real. I'm going to choose this that has the I. You see that? It has the I. So what key am I going to press? F2. Okay, so I'm going to press F2. And I'm going to change that to where the I is. I'm going to exit now. And I'm going to press enter, and this time it's not going to give me an error. This time it's going to give me 2i. Isn't that what we said that we were going to get? 2i. 2i is the answer, but this time the calculator is looking in the right place. Questions? Okay, look what I'm going to write now here. This will be very nice if you remember what happens in lesson number 3. So the answer was 2i. How many answers are we expected to find? 2. But then I still have a problem because I only have 1. How do I find the other one? Negative 2i. Remember the conjugate that we learned? Some of you already learned that in lesson number 3. That's why we go to lesson number 3. But even if you didn't go to lesson number 3, remember what I said is positive and negative 2, the square root of 4. Now, Mr. Pineda, I do not believe you. What happens if you put P of 2I in the equation, the original equation? What number do you think you're going to get as an answer if you substitute that? What do you think I'm going to get? What should you expect to get? 0, because it's a 0. But I don't know how to do that, Mr. Pineda. That's crazy. I don't know how to do that. So for now, let's use the calculator and replace that. If your calculator is in the right world of imaginary numbers, then it should not be a problem. Look what I'm going to do. I'm going to erase everything that I have there so that I can start fresh. It says 5 parentheses. I'm going to enter what it says there. 2. Let's see how many of you can find the I button there. And let me know when you find it. In the 0. You see the 0 here? It's going to be Shift I. You close the parentheses. The equation says it has to be square plus 20. And then I press enter, and what do I get? 0. Is that what you were expecting to have? Yeah, because that's a 0. You're supposed to get a 0. If you get a 0, it's a solution. And I have fulfilled my promise. Degree 2, 2 answers. There you go. Those are the 2 answers. By the way, if you put the minus there, if you put the minus in the equation, you're still going to get that because it's square, right? You understand that you can substitute that and you're going to get a 0 here and you're going to get a 0 there. So we are okay. We were just looking in the wrong place. Okay, can I move on? Okay, so now we know what imaginary numbers are, but there is something called complex numbers. 2 things, a real number and an imaginary number. If you put it together, it's going to be called complex numbers. Now, complex number is, believe it or not, every number that you have ever seen in your life, including the group that I have here, can be converted to complex numbers. Everything. The problem is that your teacher never told you that. But every number is complex. What do you mean every number is complex? Let me give you an example. Can anybody give me any number that they want? Any number. Someone here gives me an example of any number. You afraid to say a number? 10. All right, that is not a complex number because it only has real number. This is a real, right? The negative value in the square root. Let's continue with this before Noel see completely. Now the word, I didn't want to say names, but now it's going to be forever YouTube, the name. All right. You know that before the internet, we didn't have internet, so the only thing that we had is video cameras. And I had one student that videotaped all my classes, and they were in the library. So you could have gone to the library and you would have said, could I see Mr. Pineda's class, lesson 1 on April, whatever it was? And then library will give you the copy and then you can take home. And then you watch it in your big TV that you had at home. But now, thank goodness, we don't have to do that. It can be in YouTube. All right. And besides, I learned that a lot of people used to have like parties with my videos and just throw pieces of paper and all kinds of different things at the screen just to make fun of me. But those videos are not in the library. I have some of them. You will see Mr. Pineda very, very young. All right, let's continue. Look at this. The imaginary unit, in other words, the number 1 or 0, like the first number, is I. I. And we can begin to have operations with I. Look at this. What is I square? I square is -1 times the square root of -1. You know that, right? Yes? No? Maybe? What's the answer of square root of -1 times the square root of -1? By definition, you should know. Remember this. The square root of 2 times the square root of 2 is 2. Because this is 2 times 2 is 4. The square root of 4 is 2. The square root of 3 times the square root of 3 is, guess what? 3. The square root of 4 times the square root of 4, guess what? 4. The square root of x times the square root of x is equal to x. The square root of Benavides times the square root of Benavides, guess what it is? Benavides. So, what is the square root of -1 times the square root of -1? -1. By definition. Not because it's true, it's by definition. Because once you have a rule, you can't change the rule. So, by definition, it's that. So, what is the square root of, the I to the 3rd power? Well, that is the square root of -1 times the square root of -1 times the square root of -1. Right? Is everybody okay? Well, we know that these two are -1. And we know that this one is I. So what's the answer? -I. Yay. So, I to the 4th power is square root of -1 times the square root of -1 times the square root of -1 times the square root of -1. 1, 2, 3, 4. What do you think is going to be the answer? Positive 1 is correct. Well, we know that these two are -1. We know that these two is -1. Just look at the first one. And if you multiply -1 times -1, you get positive 1. Yay! Now, in the past, I used to teach, because calculators didn't have this function, I used to teach a way to do this. Now I don't waste my time. Let's go to your calculator and see if your calculator can do this for you. All right. Let's go over here and let's erase everything that I have here. And let's do I square. Shift 0 square. Look what I get. -1. What happened if I put shift I to the power of 3? -I. Isn't that what we were expecting to have? So you can go I to the power of 4. It's 1. By the way, in the regions, sometimes they say, what is the power of I to the power of 90? Sorry. I pressed it wrong. The I to the power of 99. -I. Because the only values that you can get is 1. Did you guess what are the only values that you can get? 1. You can get -1. -I, you can get an I. Those are the only possible values. There's only 4 answers. So In the past, students didn't have calculator. By the way, most teachers don't teach the fact that you can use the calculator, so a lot of students have to do calculations to find something like this. And I used to teach a way to do it without the calculator, but for what, right? You're almost falling asleep with this. Imagine if I teach you the other one, you will die. So we're not going to do it. Is everybody okay? All right, so we can do all kinds of operations. It's raised to the power. This is called the circle method, which, by the way, I'm just going to show you real quick what is the circle method because I put it there. The only answers that you can get is 1 and -1, I and -I. These are the only answers that you can get, right? I'm not going to go into details on how to use the circle graph because you have your calculator. Questions so far? So we're getting more into this imaginary world. By the way, if you get an imaginary answer, it means that there is no x-intercept. Did you get that, right? Yeah. All right. I just want to make sure that it's in your head there. All right, let's move on to the next series of exercises. Okay, let's do 1, 2, 3, and 4. It says simplify each number by using the imaginary number I. Okay, at this moment, see if you can do it by yourself. Look at -100 and -2 and -48, -36. Let's see if you can work it out. I'm going to give you 1 minute because I don't want to stay quiet for too long. People might think that YouTube got stuck. Thank you. People are thinking right now, I should have stayed in Algebra 1. But everything was Torres. Ooh, Torres is going to be forever in YouTube. I use the word Torres. Oh, I'm sorry. I thought I was giving you, before when I used to bring the camera here, before the internet and the phones, people were like, wow, I'm in the video. But now it's true. Those videos were filmed 25 years ago. So some of the students there, they are like 45 years old now, 40 years old. Okay, let's see if we can get some of this stuff going, right? Try it at least, See how they divide. The first thing you want to do is to divide the good part with the bad part. The good part with the bad part, right? I just want to get rid of that negative value, which is not good. I don't want to have that negative value with the positive value. So the first thing that I do is I separate that section that I don't like, that section that is not good, puhao. It's good. And now we know that this is I. By definition, this part is I. So the only thing that I have to do is work on the other section that you probably know how to work out. Hopefully you know. What is the square root of 10, of 100? I already said right there. Thank you. It's 10. By the way, people like to put the number first and then the I. They like that, right? They call that AI form, where the number goes first and then the letter I, right? It's just a way to have everybody do the same thing. Okay, we do have a problem with the second one because square root of 2 does not have a perfect square root. So there's nothing we can do and we have to leave it that way. There's nothing we can do because it doesn't have a perfect square root. The last one is easy. Very good. The square root of 36 is just 6.
What about the sign?
Well, we understand that it's positive and negative, right? Every answer here is positive and negative. But just to make things a little simple, we're going to leave it just like positive 6. Now, this number is a problem because this number can be subdivided into two pieces. Do you remember that from Algebra 1? What are the two pieces that, because 48 does not have a perfect square root. So what are the two pieces that if you multiply them, 16 times 3. One of them have a perfect square root. This is 4. This one does not have a perfect square root, so it's just that. And don't forget the I. And now we have your final answer. It's kind of bulky answer. It has many different things, but that's my answer. Oh my God. Let me go back to kindergarten, please. It was so easy in kindergarten. The only thing I had to do is to play with dough and put things together. Okay. Please. All right, let's continue with this. Is everybody okay? Had to simplify real numbers or into imaginary numbers, right? Okay, let's go back to the lesson and move on. Now, this is another interesting thing. Real numbers have multiplication, division, addition. You can graph them. You can do almost anything that you want. Well, complex numbers also have the same thing. You can graph them. What? Yes, look at this. Just when you thought that this cannot be even get more difficult. Zoom, zoom. Zoom, zoom, zoom. All right, let me go back to the lesson and erase this. All right, let's do number 5 here. If you look at this, my friends, we have the x-axis and the y-axis. But this is not your regular x-axis and this is not your regular y-axis because you have complex numbers. And if you remember, complex number is when you have together. What do you have together? Real plus imaginary. So this x and y axis has to have both. The x axis is the real numbers and the y axis is the imaginary numbers. Yes? Okay, so let's do a quick view here. We're going to put 1, 2, 3, 4. I'm going to make everything 5 to make my life easy. 1, I, 2, I, 3, I, 4, I, 5, I. Here is going to be -1, -2, -3, -4. I don't have space for that, so forgive me. What do you think is going to be this side here in the bottom? Negative minus 1i, minus 2i, minus 3i, minus 4i. Yes? So the graph in this case is just going to be here, 5i. This was easy because it's just one number. Let's try the other ones. let's try, let me use a different color and use the same system here. 6. It says 3 plus 2i. So I'm going to go to 3 and then I'm going to go to 2i. 3, 2i. Right? Now, the only problem is that it looks like you have to make a line to it. And then you go an arrow. And that's 2i. That's 3 plus 2i. Okay, let's do the other one. Well, this is 7, Mr. Pineda, and I don't have 7 because you only got to 5. I'm going to have to extend that. Is that okay, Torres? Okay. Yes, to you. I'm talking to you. Let's move this a little bit towards the right side. Only because we're lazy and we want to extend this. I don't know why this is not extending. There you go. Now let's go to color red and go 6 and 7. We're going to use a different color for that one, maybe a blue one. It says 7. Now, question number 7 says 7 minus I. I'm going to go to 7 because that's the real. The first is the real. And then it goes 1 down. And that's it. And then I make an arrow. I make an arrow from the 0, 0. Makes an arrow. There. And that is the answer for number 7. Questions? Why do you make arrows, Mr. Pineda? Because this is, you're going to learn that in physics, hopefully. Those arrows have a name. They're called vectors. And we need vectors for something else in math also. So I am preparing the work so that your next teacher in calculus or your next teacher in pre-calculus will have an easier time than I had. 8. Let's see if we can do 8. It's minus 4 plus 9i. I don't have 9i. We're just going to end the standard that we have. So it's going to go negative 4 because that's the first thing that you do, the real. And you go all the way to 9, all right? Let's just say that that's it. Just, please, amuse me. And say that that is the one. I make an arrow here. And actually, I'm going to put the name of it. The name of it is, like people like to put, especially in science, they like to write it like alongside 9i. Right? And this one was, the blue one was 7 minus 1i. All right? So that's it. You can do all kinds of operation with these graphs, but we're not going to do that because it's not required in this class. But we can do different operations, addition, subtraction, multiplication of vectors, which if you study computer science, that's what you need to create GPS technology, vectors. Okay? And you need to be able to multiply vectors. As a matter of fact, there is a whole class in college where you can multiply vectors and divide vectors, and they're called linear algebra. Don't take that class.
Why's that?
Unless you love math. Because it's going to take you to places you never thought that math existed. All right. Just kidding. Hopefully you get to college and you take all those classes and you come back to me and take my position. All right. Any questions with this?
No.
All right. Yes, sir.
Can you put 7 minus I because putting 1i?
Say that again on this one?
Yeah, can you put 7 minus I because putting 1i?
Yeah. You don't need to put the 1. But right now we're learning, so it's there. But as you get experience, you don't need to put the 1 there. Questions? All right. We're almost there, I think. Okay. Can we multiply using vectors? Yes. As a matter of fact, if you remember correctly, at the beginning of the lesson, I believe we had a multiplication that we couldn't do. Remember this multiplication that we had here? That we had to use the calculator to do it. But now you won't need the calculator to do it because I'm going to teach you how to do it without the calculator. So, let's try the first one. 9 plus 6. Ooh, I don't know why it's doing that. It's trying to save 9 plus 6i plus 2 minus I. This is an easy one because the only thing you have to do is to add similar terms, right? So you add 9 plus 6i and you put the similar terms underneath and you get real, only with real. 9 plus 2, please don't carry, plus 6i minus I plus 5i. Yeah, that was easy. Let's try the next one, number 10. Somebody's enjoying this a lot. Okay, it's all right. Maybe she knows already. Minus 12i, I wrote it too close. Minus 12i minus, this minus will change everything there. So it's going to be minus 3 minus 3i. Please add the i's together. Minus 15i minus 3. But remember, we like to put the real first and then the imaginary number. So we're going to put minus 3 first, minus 15i. Just so that we put them in the right order. Everybody okay? All right, now we're ready for the multiplication. La multiplication. Escribir le papier, le bon répond, fait de multiplication. Merci. All right, let's multiply. Let's use a different color so that we don't get confused. Some of my friends here get confused very easily. All right, the first multiplication is minus 2i times 5. What do you get there? 10i. Minus and a plus is a minus. 2 times 4, ai squared. Is everybody all right? Now, this is 10i, but we know that I square. Do you remember what was I square equal to? Minus 1. If you don't know, you can put it in the calculator. So now we can simplify a little bit more. 10i negative 8 plus 8. But we need to put it in the order that we like. It's not a problem if you leave it like that. It's going to be plus minus 10i. You don't need to put the plus there. Is everybody all right? You will see this in the regions. They will give you operations with imaginary numbers. Make no mistake about that. This lesson is already online too. You can look at it online. My notes are there, not the video. The video is being filmed right now, my friends. The notes are there. There is only one thing that I have left for you. And some of you are like, I'm sorry that I'm teaching the lesson. I usually like to interact with you, and we will do that. But because we are recording, I need to have a continuous voice. I'm sure you understand. All right, next and the last one. Can we divide complex numbers?
Yes.
Yes. It's very simple to divide. No, it's not simple to divide at all. Okay, let's go to 5 plus 4i divided by 7i. Well, the very first thing is you can write it like this. Yes? The second thing is we are going to multiply it by its reciprocal. Remember what we say, the conjugate? Actually, I should use the word conjugate, not reciprocal. What is the conjugate of 7i? Minus 7i. Conjugate means the opposite. And you multiply it with 7i, and you are actually, that's why they call it division. Do you remember when you were learning division of fractions? You, instead of dividing, you switch the fraction, the second fraction, by the reciprocal, and you change the sign to what? Multiplication. I hope you remember that. You have to know how to multiply. Let's remember. How do you divide 3/4 divided by 1/2? Recall, right? It's 3/4. You change this to multiplication and you use the reciprocal of that. So you get 6 and 4. We're doing exactly the same thing, but with imaginary numbers. So now we need to multiply this, and I already show you how. I'm going to go back to this in a moment. How do you divide this one? Well, you multiply it times what? 3 plus 2i, 3 plus 2i. So this is the same. How do you divide this one? You multiply by the conjugate of the denominator. Plus 3i, 2 plus 3i. I'm going to do this one only because it's the most complicated one, and you can do the rest by yourself. Can you multiply that? Yes, of course I can multiply that. It's so simple, right, Mr. Pineda? Okay, you ready?
Yeah.
This one times that one is going to give me -3. Yes? Okay, that one times this one is going to give me -2i. So far, so good? I'm going to multiply these two. It's going to give me positive 15i. Why am I putting there? Because it's the same i's. And then the last one is going to give me, who can help me with that? 10i squared. Now we can add this. We're going to get -3. Here we're going to get positive 13i. And don't forget that I squared is -1. So what are you going to get there? -10. I squared is -1. Can you put anything together there?
Yes.
That would be -13 plus 13i. So that is the top of here. -13 plus 13i. Now let's do the bottom. Okay. The bottom is 3 plus 2i. 3 plus 2i. See if you have a little bit of, a little bit of work, and see if you can figure that one out. Don't forget to multiply this, that, these two, and those two. That will be 9 plus 6i plus 6i minus 2i squared. Is everybody okay? Okay. Oh, plus, sorry. That's what you were saying, no?
Yes.
Let's take a look. I'm so sorry. I feel so embarrassed. And it's taped. All right. 3 times 3 is 9. 3 times 2 is 6. 3 times 2 is 6. And 2 times 2 is 4. Sorry. Is now better?
Yes.
All right. So let's add this. This is 9. This is 12i. But don't forget the I squared is -1. So this is going to give you 4. You can put these two together and it will give you oh, the first term.
The first term was 3 minus 2i.
This is not 9?
No. Negative 2i.
Negative, this one? Oh, did I make a mistake on there? Oh, yeah, this was minus. Oh, my goodness. Now you tell me. Now you tell me. Now I got to correct it, otherwise it's going to be in the video forever. Cut it, edit it, right? So we got one of it's going to be positive and the other is going to be negative. Yes, you're right. Thank you. That's what happens when this is going to be negative. So this is going to be 0. And this is going to be negative 4 and 9. And this is going to give you, it's going to give you what? 5, right? So the only answer that you have is 5 for the bottom part. And the answer here is going to be 5. So we finish our division here. Wow. All that for that, right? Because this is imaginary number. This is a different world now. Ah. This is the end. I don't want to talk about that question. You can do that by yourself, the last one. Listen. I don't want to forever in the video say, listen. Wow. Please try to do the last question by yourself. It's a very simple question, but for now, we have finished that lesson, and now you're responsible for that. So let's stop the stream.